Hey, we're back in the lab. Welcome aboard. Look at that. I got my goggles on this time, right from the start. All right, so today we are going to do a stoichiometry lab. We're going to find limiting reactants. We're actually throw a little percent yield in there as well. You guys won't be able to do percent yield yet, but guess what we're covering on Friday? A little percent yield. So just sit tight. You guys won't be able to finish this lab immediately, but you'll be able to do most of it today. And next week, then we can bring it to a close. So hopefully you guys have access to the lab. And here it is on canvas. But we are looking for these 7 items. Here they are. Electronic balance here. I've got my 3 beakers. I've got my funnel paper here. My filter paper, funnel, and glass fluoride. So we are ready to get going. First step, so we're going to take our funnel paper, and this is the filter paper, excuse me. This usually looks like a circle, and we're going to fold it in half. So you got like a half circle there, half moon. And then we're going to fold it again. So you almost have like a triangle here. So fold it into quarters. And before we do anything, I'm going to go ahead and write my initials on it. When we're in class here, we're going to set these all to the side. It's going to be something I want to identify. So there they are. Got my initials on there. Can even put my period. I'm in period all. I've got all periods. There we go. This way I'll be able to find my funnel, my filter paper, excuse me, when we're all done. Okay. So first step then, I need to find the mass of this paper. I'll turn it so you guys can see it there. All right, make sure we're zeroed out on the balance. So reading zeros, I can always hit the tar button to zero it if you're not zeroed. I'm going to go ahead and find that mass. And there we go, 1.04. Now that should be in grams. You can check that right there. And sure enough, little g, we're in grams. So on my lab, this will be upside down to you. Sorry, I'll flip it around once we get it. So put my name on here first. And the first thing we're doing is building a data table. Data point number 1, and you guys can see from the lab here is the mass of your filter paper with your initials on it. 1 point, and from our balance here, 1.04 grams. So that's data point number 1. Don't forget the grams part. Units are uber important in this class. We don't recognize that already. All right, so that's number 1. All right, cool. Step number 2. Well, we already folded our filter paper, sweet. And now we need to find the mass of our 50 milliliter beakers. We're on step 3. The 50 milliliter beaker is the really small one. So here that is. I'm going to dry this out real quick. Don't want any water in there or on it or anything. All right, so there we go. Let's dry it so I can get it. Okay, double check, make sure our balance is zeroed out. And there we go. And you guys make sure to record this value. This is our at-home value here. This is 31.82 grams. So data point number 2. $31.82 grams. Again, that is our mass of our empty 50 milliliter beaker. All right, now the next part. So we're on to step 4 is we're going to obtain some calcium nitrate from your teacher. For me, well, I've already got mine sitting here ready to go. So here's my calcium nitrate. Just looks like a white, fine white powder. That's what a lot of salts look like, actually. So here's my calcium nitrate. I'm going to go ahead and pour it into my little beaker here. As much as I possibly can. There we go. And now I'm going to find this mass. Make sure it's zeroed out. Got 31.92. So some of you guys already in your head, some of you guys at home. Some of you guys at home are probably already doing the math in your head and figuring out how much of our calcium nitrate we have. So that was number 3 there. Number 4, we need to find the mass of our 100 milliliter beaker. So the 100 milliliter beaker is the middle-sized one. So make sure it's 0 to place that on there. And I'm reading 52.0304 once it settles. Oops, otherwise jumping. I'm going to call that 52.04. That's data point number 4. And perhaps it will be helpful for us to kind of record what we're doing here. So this is the filter paper. A lot of numbers. This one here is the empty 50 mil. This one here is the 50 mil plus, what did we put in that one? Oh boy. Plus our calcium nitrate. And this last one here is our empty 100 mil beaker. So that might come in helpful for us later, so we know what all these numbers are. And now we're looking for our 5th data point. Okay, let's see here. We determined the mass of our 100 milliliter beaker. That was step 5. So now we're on to step 6. Now we need a sample of sodium carbonate. We'll add this to our 100 milliliter beaker. Cool. So here's our sodium carbonate. Again, it's a white salt. It looks really similar to all the rest of them. There's a lot of white salts out there. I'm going to put this salt. There we go. Got my salt in there. And now I'm going to find the mass of my sodium carbonate. Let that settle for a second here. 52.12 grams. All right, again, I know some of you guys are probably doing some mental math and already figuring out, okay, how much calcium nitrate do we have and how much sodium carbonate do we have? Well, we'll come back to that. We'll deal with that when we get to our calculations part. For now, our next step, number 7, we're going to add a little bit of distilled water to each of our beakers. And we're going to kind of mix them. We use a glass stir rod to kind of mix them around and see if we can't get those salts, those white salts, to dissolve. The overall volume of water is not terribly important for this lab. We're not going to worry too much about the water. The instructions say add about 20 milliliters. Again, the overall volume is not important. It's close to 20 milliliters. I'll add about 20 milliliters here. I want these salts to dissolve. The little beaker, that one dissolved quickly. I don't know if you guys can tell. Probably tough to tell, but you can't really see any salt in this one. So that one dissolved very quickly. And that should help your states of matter you guys are writing your balanced chemical equation. What state of matter do we put when we say it is dissolved? You guys should know. A big thing then, I want to make sure I kind of rinse this off. Again, the overall volume of water doesn't matter. I want to make sure I rinse this off. So I'm doing here. So I don't transfer any of the salt particles they're in the water. They're dissolved in there into this one. Okay, this one needs a stir. You guys can probably tell. You can see there's some salt particles in there. Let's see if we can't get them to dissolve by stirring. Add a little more water. See if that helps. And the overall amount of water is not terribly important for this lab. We're using distilled water. You can see that here. Distilled water, that famous blue lid there. It's better up here, back there. Distilled water is, theoretically, it's perfectly pure water. So we're not adding, you get water from your faucet. You've got some iron flakes in there. You might have some nitrates in there from the ground. I don't want anything in here. I want my solution to only be the salts I'm putting in. And so I use that perfectly pure water. All right, again, I want to rinse this off. I don't want any residue on my stir rod. Cool, and you can see we got this salt to dissolve as well. Took a little more stirring, a little more water than the other one, but these two look like two perfectly clear substances. They aren't. We know. You guys saw me put those salts in there. So there are dissolved salts in there, but that's what it means to be aqueous. Dissolved in water, you can't see them. I can't see them. It's almost like they aren't there. Clear water. All right, our next step here then. Our next step is we are ready. Step 8 there, we are ready to add the folded filter paper into the funnel. We got to make sure it's opened properly. So the idea here is we've got our filter paper, we folded it up. You guys watch me do that. We folded it up into almost like a pizza shape here. Well, we only want to open up 1/4 of it. We want to make sure that when we open it up, just opening up 1/4, that there's no hole in there. So a lot of people open it up like this and like, oh, look at that. But you guys can see there's a hole in the bottom. That's not going to do anything. We want to catch the solid particles. So again, we only want to open up just 1/4 of it. And that way, no hole down there at the bottom, hopefully. Catch all the solid down in there. I'm going to get my funnel. I place my filter paper in the funnel. If you ever have problems with, you can see it kind of bounced out there, it's not staying in shape, add a little bit of water. And the water is not terribly important today, the amount of water that we use. So add a little bit of water. That gets it's kind of hold its shape. We're going to place the funnel into the 250, the largest beaker that we have. And we're ready to go there. Step 9. Step 9 is we're going to mix the two solutions, the 50 milliliter and the 100 milliliter. We're going to pour them together. Let's see what happens. We'll pour this perfectly clear substance into that perfectly pure substance. Well, that was interesting. You see that? I want to give this little one a rinse. There's still some residue in there. I want to make sure I get everything out. Otherwise, I'm not going to have a very good percent yield. So a little rinse here. There we go. Cool. Yeah, any indication of a chemical change? What do you guys think? I'd say definitely. You can stir it around a little bit if you like. Definitely indications of a chemical change. Chemical reaction has definitely occurred. Again, I don't want to just take my stir rod out of here, though. Make sure I keep all of my solution. So now I got some particle in there. Put that all in there. Now we are ready to decant. So slowly, I'm going to pour my solution into my filter paper. I want to do that slowly, and I want to make sure it doesn't come up and over the edge of the filter paper. Once I've done that, well, now the solution can come up and over, and I'm starting to lose product. It'll have been draining into the bottom. This is going to be like watching paint dry. It's quite a slow process here, but as we kind of wait for this to occur, I'm going to get you guys started on some of your data collection on the backside of the lab. Very slowly, just kind of letting that drip. And I'm going to transfer over to the backside. So this is the second page of the lab here. And the first thing we're asked to do is determine the mass of calcium nitrate. So kind of back to my data collection here. So here's my data table, and I am going to have a sixth point of data, but I'm not going to be able to get there until next week when we come back and we look at our dried filter paper. So I'm going to leave that blank for now, and I'm skipping maybe a line or two here. And I'm going to go down and I'm going to start a new column called the calculations. And again, problem 1, they ask, what is the mass of calcium nitrate? Now, they ask, this is huge. Do not be lazy. You need to show me all of your work, including units and proper digits. Don't get lazy. It's not time to get lazy on me. This is a lab. You guys will be graded as such. So big points off for doing the wrong thing. So let's do things right. All right, first thing we're looking for, mass of calcium nitrate. Well, I can look up at my data, and I know calcium nitrate and the 50 milliliter beaker. There's the mass. The empty fill milliliter beaker, 50 milliliter beaker, there's the mass. Now, a lot of you guys can probably do this in your head, but I need to see your work. So 31.92 grams. There's our beaker and calcium nitrate. And we're going to subtract the mass of the beaker. In units behind everything. In fact, this one probably should say 50 milliliter plus calcium nitrate. And this one probably should say just 50 milliliter beaker. So when I subtract out the mass of the 50 milliliter beaker, I'll be left with my remaining amount of calcium nitrate. 2 from 2 is 0. 8 from 9 is 1. Drop the decimal point, 0 and 0. Make sure we have our units of 0.10 grams of calcium nitrate. Let's check for significant figures. Again, it matters how far behind the decimal. This one goes 2 places past the decimal. That one goes 2 places past the decimal. So guess what? We are spot on at 2 places past the decimal. Fantastic. So there's our mass of calcium nitrate. Calculation number 2. For calculation number 2, you guys are asked to determine the mass. Don't need to hold it upside down. I've got the camera right on here. All right, so for number 2, you guys are asked to determine the mass of sodium carbonate. Again, you need to show me all your units and your proper digits. I need to see those just like we did in this problem up here. So I'll give you guys a minute here. I'll check on our sample over here. Still splish splashing away, still draining properly. Once you guys finish up with this calculation, again, I'll give you another minute or so here. No race. We're still waiting for our solution to filter, to decant. But once you're ready for it, question 3 of the calculations, hey, this is the big one. Stoichiometry always starts with a balanced chemical equation. So number 3, you guys need to write the balanced chemical equation for calcium nitrate reacting with sodium carbonate. So you're going to need your periodic table. You're going to have to use the backside of your periodic table with the nitrates and the carbonates. You're going to have to use those charges. You have to balance for subscript, then balance for overall numbers with coefficients. And then this is big. I know a lot of you guys don't like using your states of matter. Guys, you have to use those solubility rules on the back of your periodic table. You have to solve for your states of matter. And here's why. Here's why. You guys remember when we combined the solutions, and they turned a white powdery colored material there. Rewind the video and go back and look. We have a white powdery video. Why is it white? Why is it powdery? That's because we have one solid product. That product is solid. So that's why you have to use your solubility table on the back of your periodic table to figure out which of our 2 products, only one of them of the 2 is going to be solid. Use the backside, determine your states of matter, write a balanced chemical equation, and that's step 3. Again, I'll give you guys a few minutes to work on that. I'll continue to filter and decant. So we're pretty sure we're making good progress because the water that we're pouring through the filter is clear. So we know we're not really losing any product there. Every once in a while, some busts through, and then this whole thing turns cloudy, and you're like, man, I ruined that. But it's still clear. Again, compare that with the solution we made, which we're still decanting. So we got a little bit left to go there. And look at that solid. You guys can see, that those white particles in there. Those are solid. We call those in chemistry, we call them precipitate. That's a white precipitate. Again, you need to balance chemical equation. You need to use your solubility tables. You need to figure out what that white precipitate is. Which of our 2 products is solid? It's not dissolvable in water. We can see it right there. It didn't dissolve in water. We mixed our 2 aqueous solutions, and we got a solid product. The other product, so again, we're going to make two products. Give you a hint. We're working with a double replacement reaction here. Double replacement. So the other product, we're making two of them. The other product, well, guess what? That's still aqueous. It's going right through the filter paper. And it's coming right out into down here. That's why this is still clear. Still looks just like water. We do have something in there, but it's dissolved. We can't see it. At this point, you guys can kind of see how the funnel's starting to get covered there. Funnel's starting to dip into the water. I'm going to pour out our water. Again, I know I've done a good job because it would have that white, cloudy appearance if any of my product had gotten in there. It's still really clear. Doesn't look like there's any solids. I'm going to dump this out down the drain gills. Cool. A little more room for my funnel to continue to drip. Getting close to the end here. And again, while we're kind of waiting on all that to happen, you guys have a balanced chemical reaction at this point. Now it's on to question 4. What is the product? What is this white material here? What's in there? Again, the way to figure out what the product is to figure out from your balanced chemical equation which one is solid. Once you figured out what your product is, now you're ready for your stoichiometry. And again, you guys can do this while we're kind of sitting here waiting for this stuff to drain, just kind of watching paint dry. 5A, determine the theoretical mass of solid product that should be formed from each reactant. We have 2 reactants. We have 0.10 grams of calcium nitrate. That was one of our reactants. And in question 2 here, you guys figured out a mass of sodium carbonate. That was our second reactant. So use your stoichiometry and convert from 0.10 grams of calcium nitrate to your stoichiometry and figure out what mass of product we should have. That is step 4. So step 4, you guys need to answer what the product is. Step 5, you need to write 2 stoichiometry problems. Problem's the right word. 2 stoichiometry. I'll go ahead and keep problems. 2 stoichiometry problems to solve. Two stoichiometry problems that are going to be used to solve for how much product should be formed. And the product is the solid from your balanced chemical equation. And that's going to take you guys a few minutes. You definitely need your periodic tables. Find your molar masses of the 2 substances you guys worked with. Almost certainly have to go to the back side of the table too, or that back side of this paper too. Keep this over and keep working. And I'm just still watching our solution go. Fun times here. Okay. By the minute, working on your stoichiometry. But you'll notice I'm out of liquid in the 100 milliliter beaker. I have poured it all through. It's slowly draining again, but also, hopefully you guys can see, there's still some white residue. Some of our solid product is still in here. I don't want it in here. I want it in that filter paper. So in order to get it out, I'm gonna add some distilled water, kind of make sure I get the sides of the beaker. I want to get all of that white stuff. Get a rinse here. And guess what? I need to pour this through the filter paper. Nice and slow. Again, don't want to go up and over. I've done a really good job so far. You guys can notice, we're still got clear water there, so it doesn't appear as though we've lost any product. And I'm try to get all that salt. You can still see there's some white in there. Still some salt. I gotta get that all into the filter paper. So I'm going to go ahead and try it another time here as soon as that continues to drain. So it's a nice slow lab we work on here. No rush. And you guys are probably still working on your stoichiometry and make it look pretty. It's a piece of artwork you guys should be turning in. Kind of start to clean up some of these other parts of the lab. So since this is still clear, I know I haven't lost any product. I'm going to go ahead very carefully and pour out the filtrate. Sometimes when it starts to build up around the funnel, it seems to slow down. And still got this little tiny bit of salt left. I don't know if you guys can see that or not. Still working to get all my solid through there. Ah, man, still got some. Kind of frustrating. Definitely can see that, right? All that white needs to be in my filter paper. So another rinse. Actually, we got some on the side there. It looks like do my best to make sure it drips into the filter there. Set up for tomorrow. Make sure to rinse this off. And for those of you guys at home watching the video, make sure you guys are coming to my office hours or coming to recitation on Friday. If you're stumped on any of this, again, labs are worth a lot more points than just your typical homework. So if you're stumped on this, not sure what's going on, Missing stuff, you need to come in. You need to make sure you come in. You need to make sure you ask me. Because if you miss a lot of points on this, it's definitely going to affect your grade. So if you're not sure about the balancing or the stoichiometry part, recitation on Friday, be there. Not sure why Noah decided to write his name on their beaker here. Ugh, frustrating. So just slowly letting that water drip through there. Man, exhilarating watching this happen, huh? It's almost as good as being here watching it happen. And let's see if we can get one last good pour and get all this white powder in there, huh? Did we do it? Did we get it all in? Oh no, there's still just a little bit left, man. Be here all night. But I want really good lab results. I always want really good lab results. I always like to do things best as I possibly can. So take our time and we'll do this right. And again, we've done a good job so far. We can tell our water is still clear here. It's coming through, so we know that we haven't lost any product, or we probably haven't lost any product. We'd have that kind of white murky color down there if we did, if we had. It was about this time in the lab last time when I realized I wasn't wearing my goggles. I had to go grab them. Well, took care of that from the beginning this time. And I think we're ready for our final pour here. Just I hope that's our final pour. Oh boy, just a slight bit less. I'll give our beaker one last little rinse here. I think we got it. Looks pretty clear. Looks like we got most of it. So now it's just kind of a waiting game. Let this funnel through. So much there. Well, just a waiting game here. So just waiting and letting this drip, drip, drip. And I'm going to go ahead and dump it. A little more room here. Just a little bit left. Just a few last few milliliters. And we should be good for the evening. And again, just kind of letting it do its thing. So we are so very nearly there. So a little tiny bit of water left in the filter. I think it was fine. Had quite a bit of time. The first few there, you use more. Hopefully this time, you guys have figured out the two stoichiometry problems, and you've been able to figure out how much product we should be able to form. So question 5B from the lab then asks, what is the limiting reactant? And question 5C, what is the excess reactant? So there's 5B and 5C. And of course, that's going to depend upon your values from up here. Questions 1 and questions 2. Some of you guys might have calcium nitrate as your limiting reactant. Some of you guys might have sodium carbonate as your limiting reactant. That's absolutely all right. In fact, you should have some different values. It kind of depends on how much you started with. You didn't start with the same of both. So which is your limiting reactant, which is your excess? And again, how much product should have formed? Well, question 6, you might already be on the back. In fact, you probably should be. But when you get there, for question 6, we're going to need to wait until we come back, probably on Monday. So when I finish up here in just a minute, what I'm going to do is I'm going to take my filter paper, going to fold it over. It's still going to be sopping wet, and I don't want that wetness. That water, I don't want. All I want is my solid product. So I'm going to take my sopping wet mess of a filter paper. I'm going to fold it in half. I'm going to set it over to the side. I'm going to wait and let it dry out over the weekend. So when I come back in, we'll finish this lab up on Monday. The first question we'll ask is how much product did form. And of course, we'll figure that out on Monday. How much did we actually get? We'll remask that now dry filter paper. And that'll be data point number 6. And using that, we can subtract out the mass of the dry filter paper and figure out how much product is in the filter paper. And finally, then, question 7 is a what is the percent yield question. And of course, you guys don't know the answer to that just yet. You're going to have to watch notes on Friday. We haven't covered that. We won't until Friday. So we'll come back and we'll do that on Friday. But for now, let's see how we're doing. We're probably very close to finishing up. And still have a clear filtrate down at the bottom. That's excellent. That means we did a pretty good job of making sure that all of our solids stayed in the filter paper. And yeah, we are very close. Again, just a couple more drips here, so we can help it out. Couple more drips, and we should be good to pull out our filter paper and set it aside for drying on Monday. Let's gather there. Come on, little guy. Hooray! There it is. All right. Boy, the excitement of chemistry. All right. Yep. Is that one more? Can I help that guy out? He's hanging in there. One last little drop. Yeah. All right. We're going to call that a day. I'm going to go ahead and pull the filter paper out here. Carefully. Very wet as I pull this guy out. Kind of, again, close it up. It's kind of back to being flat. Don't want any of that solid to fall out of it. Kind of close it up. And again, I'm just going to set this over. There on the side. Flip it over real quick so that my name is there so we know who we're looking for. When we come back on Monday, there it'll be. All right, guys, you've got most of this lab complete. Again, we're going to have to wait till next week to finish it, but you should have most of your data at this point, a couple of balanced, or one balanced chemical equation, a couple of stoichiometry reactions. You should have your theoretical yield. How much mass did we think we'd come up with? Should have all that done by now. And again, I cannot emphasize this enough. come to my office hours or come to recitation on Friday. If there are things you're not getting, you need to come see me in person so I can help you work through it. I'm very willing and wanting to help you work through it, but you got to take that effort. You got to take that next step. You got to get there. So I'll see some of you guys, I'm sure, in office hours and recitation. And I'll make a follow-up video to this one where I'll find the mass of my solid, my remaining material. I'll find that on Monday next week. So be looking for that. Until then, have a great weekend, guys. I'll see you Monday.